A lot of research is being dedicated to find solutions to the ever-increasing energy consumption, and how to deal with its waste. Julio Darcy, the man in this picture, has tried to create a solution to this problem, with red bricks. He made it so that red bricks could store electrical energy. Red bricks consist of 55% silica, 30% alumina, and 8% iron oxide. The red color in bricks is formed by rust. Now, there are different types of rust. The red bricks consist of the hematite type. Red bricks are good thermal capacitors due to their thermal mass qualities. Due to this, Darcy tried to find a way to make them store electrical energy. He used something called PEDOT, a supercapacitor. What are capacitors? Basically, capacitors are devices which are used to store energy. Supercapacitors are high-capacity capacitors, with capacitance value much higher than other capacitors, but with lower voltage limits, that bridges the gap between electrolytic capacitors and rechargeable batteries. PEDOT PSS. Poly 3,4-ethylene dioxythiophene polystyrene sulfonate is a type of a supercapacitor formed out of the hematite in the red bricks. It is a semiconducting nanofiber. The largest application of PEDOT is as a transparent, conductive polymer with high ductility. Supercapacitors provide a superior performance as compared to regular capacitors and non-rechargeable batteries. They can primarily be found in applications that require rapid charge and discharge cycles. They are widely used in today's life. They are used in buses, cranes, trains, and elevators for regenerative braking, short-term energy storage. Red bricks are chemically inert because of the presence of hematite, or the rust which gives it the red color. Hematite is the most stable form of rust, and can be of different colors. When an acid is added to the brick, it dissolves some of the rust, and forms a solution of iron ions, which are highly reactive. One of the ions also acts as an oxidizing agent. So how is the polymer PEDOT formed in the brick? The red brick is placed in an oven and introduced to vapors of an acid, which start dissolving a few layers of the rust, but also allow the vapors to infiltrate all the pores of the brick. Then, the temperature in the oven is raised to about 180 degrees Celsius, and now introduced to the gas of a monomer, an organic molecule. This monomer on coming in contact with any oxidizing agent, at this point, the entire brick polymerizes. All the pores of the brick now contain PEDOT, a sulfur-based conducting polymer. The nanofibers are made from this polymer, which has a high surface area, like a soft nanosponge, that is, a soft plastic which is trapped inside the hard, inorganic brick and cannot escape. So, there is a soft sponge of nanofibers throughout the pores of the brick. Advantages of smart bricks. PEDOT-coated bricks can provide electric power to emergency lighting. Darcy said that around 50 bricks connected with solar cells could power emergency light for 5 hours. These coated brick walls acting as a supercapacitor could be recharged multiple times within an hour and be cycled 10,000 times before their capacity falls significantly. We can also increase the energy capacity by increasing the thickness of the polymer coating on the brick. For a certain amount of coating of PEDOT, we need to normalize the energy density either by mass, volume or area. If normalizing the energy density by area, thicker the coating, more polymer per area, thus resulting in a very large capacitance, which works, according to Darcy. Limitations. Thicker coating of PEDOT on the bricks results in slower diffusion of ions into the polymer and into the brick. Even after a 1 mm or 0.5 mm coating, the polymer becomes incredibly resistive for ions to diffuse into the brick. A way to solve this would be by aligning the pores of the brick, which will allow us to make the coating thicker and overcome the resistance of ions going into the brick. The energy-storing brick is not yet ready for commercial application because of its low energy density, but it will be ready for use in around 5 years as energy density needs an increase in magnitude. Another application of energy-storing bricks. PEDOT has semiconducting materials in it. Semiconductors act differently with the environment. They can sense a change in pH, humidity and temperature, thus acting as a sensor. The sensors are made from the hematite integrated in the bricks and can pick up any leakage, corrosion, etc. Now, since building with bricks is costlier as compared to that with concrete, brick construction is declining. The companies and the people love the red color of the bricks, so the new constructions include a brick facade, which is about 0.5 to 1 inch in width, to which the smart brick technology can also be applied. The innovation of something so beneficial from something as simple as red bricks can lead to a big step for mankind.